Percent composition. So you have a bunch of elements in a compound, and you want to know what percent of the total mass each element is. Okay, that's percent composition. The mass of the element in a sample of a compound divided by the mass of the sample compound gives you the percent element in a compound. Okay, so if you just have the formula, you don't have this mass data per se unless you assume 1 mole of the compound. And then this equation becomes the mass of the element in 1 mole of a compound, okay, which is really just the molar mass of the element, divided by the total molar mass of the compound, times 100%. So what does this look like in action? Calculate the percentage composition of sodium nitrate, NaNO3. All right, so if I calculate the molar mass of sodium nitrate, that's 84.994 grams per mole. All right, so if I assume 1 mole sodium nitrate. If I have 1 mole of sodium nitrate, I also have 1 mole sodium, because there's 1 mole sodium in every 1 mole sodium nitrate. And then I can convert that mole to a mass. Okay, so that's 22.990 grams sodium. I can do the same thing with nitrogen and with oxygen. The only thing that's different here is that oxygen has 3 moles for every 1 mole of sodium nitrate. Okay, and just as a quick check, you might want to make sure that these things add up to the molar mass, because we assumed 1 mole, which they all do. All right, so now to figure out the percentages, I just have to take the, so for example, for oxygen, I would take the 47.997 grams oxygen over the 84.994 grams of the compound times 100%, and I get 56.5%. Okay, and I can do the same thing with nitrogen. 14.007 over 84.994. And I get 16.5%. And for sodium, at 22.990 grams sodium over 84.994 grams NaNO3 times 100% is 26.9%. And then as a final check, I can add all these up and make sure that they add up to 100%, which they do. All right, so in a kind of similar, you'll see those types of problems. You'll also see some problems involving hydrates, okay? And hydrates are just sometimes when ionic compounds form crystals, okay, water molecules bind in the crystal and become integrated as part of the crystal lattice, okay? These compounds are called hydrates because the waters are actually kind of locked in. So you might see something like this where you're asked to find the mass percentage of water in this hydrate. Okay, Well, so this hydrate, basically the way you read this as, there's your regular copper 2 sulfate, but in the crystal structure there are also, for every 1 copper 2 sulfate, there are also 5 water molecules, okay? So, you know, for 1 mole of this, there's 5 moles of this, and so if I take the molar mass of this, so I take the molar mass of copper 2 sulfate, I take the molar mass of water, multiply it by 5, and then add them, and I'd get the molar mass of this hydrate to be 249.677 grams per mole. Okay, so what is the mass percent of water? Well, in order to figure that out, I need the mass of water over the mass of the hydrate. And again, if I assume 1 mole, this becomes much easier, times 100%. So I need to get both of these, really, and the mass of the hydrate is really just going to be that times 1. Okay, but the mass of the water, I know I have 5 moles of water for every 1 mole of the hydrate. So that's times 18.015 grams water for every 1 mole water. Okay, and then I get 90.075 grams water. All right, so I've got my mass of water. I take my mass of the hydrate, which I just multiply this by 1 mole to get rid of the moles. And so my mass percent of water becomes 90.075 grams H2O over 249.677 grams per mole, or grams hydrate. Times 100%, and I get 36.1%. So this is another type of mass percentage problem that you'll see.